Yo, what's up? It's your boy Mr. AC, and what I got for you guys today is a freaking stinking brand new topic called inverse functions, inverse relations, inverse operations. Now, what does that all mean? Well, we're gonna break it down, and hopefully within the next 2 weeks, everything will be put together. This topic really is going to help us understand another topic called logarithmic functions, which are really important, and they're really clutch. So before we do, let me at least give you kind of the perspective that'll hopefully help you understand what inverse means. Inverses is like the opposite of your original function or original pattern. So for example, if I take 2 steps forward, my inverse operation would be to take 2 steps backwards. If I take 2 steps to the right, my inverse will take 2 steps to the left. So if you notice, my inverse is like the opposite of what I do. So if you watch anime, right, it's like black magic versus light magic, right? They're just kind of polar opposites. They undo each other. So that's what inverses are. So for example, if you think about just operations, if I add 3, what's my inverse? I'm subtracting 3. If I multiply by 5, my inverse is to divide by 5. So you can see how that relationship works. Now, there's a couple of more mathematical definitions that we're going to take a look at, because the mathematical definitions sometimes seem a little bit odd, but you'll see where it all makes sense eventually. So let's go ahead and take a look. Well, inverse opposite of another operation. Here is the mathematical definition that we're going to use right now. And we want you to know how inverses work with a table, graph, and equation. This week it's table and graphs. Next week we're going to do equations. Now here is the mathematical definition that we're going to use for tables. It's we switch the inputs and outputs. So what that means is when you have x and y values, they swap, right? They undo each other, so they're basically going to switch. Well, how does that look like? Well, let's go ahead and come out with an example. Let's do something like this right here. How do you take the inverse of a table, right? Because we want to understand tables first, and then we'll work our way up to other more complicated problems. Now, in the idea of inverse operations, if I move 2 steps forward, my inverse takes 2 steps back. Well, that's a little bit different when we look at tables, right? Because tables have actual values there, and they're not actually operating. They're not saying like multiply by 2. They're just values. So how do we work with that? Well, I wanted to show you a couple of cool things. So first of all, we're going to go to this table right here. This is my original function, right? These are my y values right here. We call them f of x. These are my x values. So the inverse of tables is we switch the inputs and outputs. The inputs are your x values, and the outputs are your y values. So we're going to switch them. So what does that mean? Well, that means the x values are now going to become the outputs, the y values, and these outputs are now going to become the inputs, okay? So it's kind of like a little circle. You know, this table, it's x values, y values, and then we're going backwards. It's like a little bit of a cycle, which makes sense because they kind of undo each other. So if you look up here, let's go ahead and give this a try. So these are my x values. They now become my y values. So 1, 2, 3, and 5 right here. Now these y values, these outputs now become, well, what do you think they become? You got it right. They're now going to become my inputs. So they have to match up. So this is going to be -2. Ooh, let me go ahead and I wanted to make it color coded. This is going to be -2, -4, -2, and -1. So if you notice, all we did is we switched the x and the y's. That's how you find the inverse of a table. I'm going to be honest with you, and I'm going to tell you right now, us mathematicians are freaking lazy. You know we're lazy. We don't want to write inverse of f of x here every time. That can be a little bit annoying. So what we would prefer to do is we write this unique notation right here. So this is what I want you to get accustomed to. When we write this f and there's a little -1 on the exponent, that means inverse. I want you to be careful. That little -1 doesn't mean raised to the -1. That's very special just for inverse functions. So this right here, so this little notation right here is literally this exact same word. Find the inverse of f of x. That's basically a shortcut, and we'd rather do this so that we don't have to write find the inverse of f of x every time. I can just say find this, and that means you better find the inverse. So this table to the here is the exact same thing that we did. So just so you know, these are the exact same. So -2, -4, -2, and -1, and then over here it's 1, 2, 3, 5. So just showing you two different ways to write it. When you do your practice problems, you might get the problem like this, or the table might look like this. Either way, they both mean the same thing. Find the inverse of f of x, or this is the shortcut of saying find the inverse of f of x. They're both going to be the exact same thing. So hopefully that makes sense. I think the next natural question, y'all, is to then ask yourself, what's going to happen? What's going to happen when you graph them? What will it look like when you graph them? Well, I'm running out of space here, so let's just go to a new problem. So the graph of f of x is shown below. So here it is. Determine the inverse of f of x. Notice this notation, like we talked about, is a shortcut for saying find the inverse of f of x. That's what that little -1 up above means. It's very unique notation. It doesn't mean raised to the power of -1. It's just a whole brand new way of saying find the inverse. Well, what is our definition, right? Graph wise, we don't know what that looks like, but at least we can try to make sense of this. What do we know is true about inverse operations? Well, the inverse means we switch the x and the y. So here's how we need to start this problem. We are going to plot these points. Now on your practice problems, we're probably going to give these points to you because it's hard to sketch, but for now we'll go ahead and plot these points ourselves. I'm gonna just pick the 3 points that I saw the table: -4, -3, -2. At -4 it's 0, at -3 it's 2, and at -2 it's 0 as well. So there it is. So we've graphed these 3 points so far. Now we want to find the inverse table. We want to find what the inverse will look like. What is our definition? Well, remember, our definition is we switch our inputs and outputs. So this is now, right, this is my -4, 0. This is now going to become 0, -4. This is going to become 2, -3, and then we're going to swap these, and we're going to get 0, -2. Notice how even though the table is not vertical, it's horizontal, we can still switch them. We just have to be careful. Now we're going to graph it and see how it looks like. Now I want you to know, here's what I could have done. We could have gave you this table first, and then you would have to graph it, and then you can go and graph the inverse. So just know, we're going to challenge you a little bit in the formative this week. We're going to give you a table, and we're going to ask you, maybe what does the inverse function look like? Well, you might have to sketch the original first. But anyways, let's go ahead and sketch this out. So it's 0, -4, 0, -4. So I'm going to mark it right here. 2, -3, 2, -3. That's right here. And then 0, -2. Okay, that's going to be a little bit weird. 0, -2 right there. Now you can see how our shape looks like on the graph, and we're trying to understand how this is going to look like. Oh my god. Boom, there it is. So check that out. Notice how these two look somewhat reflected, right? They look a little reflected. Here's this one and here's that one. Well, let's do one more and see if we can find a pattern with graphs. So here's the graph of g of x. Determine the inverse of g. Well, I'm going to go ahead and plot some points. I love to plot points whenever I see a graph, and I'm going to actually show you 2 different ways that we can actually do this problem. So let's do this the long way. All right, we're going to make a table, and then we're going to flop them. So boom, and here's my inverse table. So it's -3, 1, -3, 1. It's -2, 2, -2, 2. So let me go ahead and fill this out real quick. If we take a look here, I just filled out the rest, right? -1, 3, -1, 3, 0, 4, 1, 5. Now, if I do the inverse, I need to swap them. So we're going to switch the inputs and outputs. So the -3 becomes the y value. The 1 becomes the x value. So notice how these just swap, these two just swapped, and so forth and so forth. So now let's go ahead and sketch our inverse function, right? So we can see how it looks like. This is going to be 1, -3, 1, -3 down here, 2, -2, 3, -1. So you can see just kind of how it looks like. 4, 0, and 5, 1. So if you check it out, there is my inverse function right here. So look at these 2 problems and see how they're similar and different. So check this out. Well, now I want you to look. Here's the inverse function for that graph. Here's the inverse function for this graph. Well, how does it look like it's reflecting? Well, it turns out, I'm gonna tell you, in class you would have had to figure this out yourself, remote learning. It turns out this is a reflection. It's like a mirror. It turns out when you do the inverses, something is happening graphically. They're getting reflected. Well, what does that reflection look like? Well, look, let me go ahead and just do this real quick. Check that out. Well, they're actually reflecting over this right here. Let me go ahead and dot it up real quick. Let me dot this line up right here. So check this out right here. This dotted line that I drew, we call this the y equals x line. So I'm gonna write it over here, y equals x line. Why is it y equals x? Well, if it's just x, it's just rise over run of 1. There's an invisible 1 here. So for example, just up 1 over 1, up 1 over 1, up 1 over 1. But the reason why we drew this line is because the blue line I just drew, my original, is reflecting over this horizontal line and drawing the inverse, right? If I show it to you, there it is. So if you notice, what's kind of cool, when you switch the x and the y's, whatever your graph was, they just reflect over this y equals x line. And what's really cool about that is the distance from this line to these points, 1, 2, is the same if I go the other way, 1, 2. So you'll notice the distance is the same across the board. Now go back over here and let's look at this graph right here. And let's see if this makes sense as well. Let me go ahead and draw this dotted line. Boom. Y equals x line right here. And let's see if the distance are the same. Well, let's look at this one. This is 1 to 1. You see the distance are the same. Let's go to this one here. 1, 2, 2.5. So half, 1, 2. Look at how the distances between this line are the same. Let's look at this one. 1, 2, 1, 2. So if you see these lines, this distance is the same from our original. So another cool thing for you to know is if you wanted to draw the inverse of a function, you don't even have to make a table. You can actually just do this right here. We can draw the y equals x line. Here it is. I'm drawing these so bad. Hold on real fast. It's hard with my mouse, but here it is. The y equals x line. I know it's not perfect. Y equals x, and we know the distance has to be the same across the board. So for example, 1, 2, so 1, 2, so I know my inverse function is going to be right here. Let's go to this line right there and let's go ahead and do the same thing. 1, 2, 1, 2. So now I'll go ahead and plot my point here, and then if I follow the same pattern, I'll see, oh, my inverse function is, oops, right there. There is my inverse function. I drew it right there, which is the exact same as this line right here. Check that out. Boom, boom. What is our big takeaways for today's learning? Well, when you do the inverse of a table, you switch the x and the y's. And when you do the inverse of graphs, you're going to go ahead and you can make a table and then put the inverse graph, or you can draw this y equals x line that we just discovered, and it's a reflection across that line like a mirror. And because they undo each other, they're gonna have those same principles, right? You can see right here, if this graph goes this distance, the other one is the same distance, right? Because remember, inverse, if I take 2 steps forward, my inverse takes 2 steps back. So that distance should be the same between that reflection. So hopefully you guys enjoyed. This is going over an introduction to inverse functions. Next week, we'll take a look at, well, how the heck do you work with equations? All right, take care. Capiche?